Hi everyone, and welcome to MathSux. This video is going to help you pass algebra. In this video we're going to go over writing systems of inequalities by graphing the solution to the following system of inequalities you see right here. Then at the end of the video there are going to be some practice problems you can try on your own. So let's dive right into it. Here is just a little review on how to graph inequalities. I have a whole video on how to do this in detail, but here's just like a quick review of the rules. So when graphing any inequality, if you're graphing greater than or equal to or less than or equal to, you're always going to want to use a closed circle and straight lines. This represents that everything included on that line is included in the solution. And when you're graphing something that is greater than or less than, then you use open circles and a dotted line to represent that the solution does not include the coordinate points within that line, because it's greater than or less than, not greater than or equal to. And as for shading, you always want to think of this as above or below the x-axis. So when things are greater than or equal to or greater than, we always want to graph things that are the top part, those positive y values. So even though we're graphing above the x-axis, you want to think about the y values that we are incorporating in the solution. So greater than, we want positive y values, positive numbers. And for less than and less than or equal to, the shading is always going to be below the x-axis for those negative y values. So all these values down here. So that's why we shade in these different directions. The only thing that's different about simultaneous inequalities, we always want to look for the solution where the two shaded regions overlap. So we're going to look at a question now. Here's our example. So it says, graph the solution of the following systems of inequalities and check. So we have these two inequalities, y plus 1/2 x less than -2. And 2y minus 2x is greater than or equal to 2. So let's just look at this first equation right here. So let's call it number 1, and let's just bring it on over to the left. So the first thing we're going to want to do to graph our inequality is to get into y equals mx plus b form. We want it in this form so we can identify the slope and the y-intercept. Notice that we just need to move over this x value, this 1/2 x. So subtract it from both sides, and then we're left with y is less than, so that less than sign stays the same. So y is less than minus 1/2 x minus 2. So now looking at this, we can identify the slope and the y-intercept. So the slope is -1/2. So you could think of this as down 1 and to the right 2. And the y-intercept, b, is just -2. Now that we have the slope and the y-intercept, before we get ahead of ourselves, we want to make sure we're using the right inequality rule. So since, remember, we have this less than sign in this inequality here, so because of that less than sign, we're going to be using an open circle and a dotted line on when we graph it. So now we can go back and look at our rules with the slope and the y-intercept and graph this using open circles and a dotted line. So we have the y-intercept is -2, 1, 2. Open circle, and then now we're just going to follow our slope rule. So we go down 1 and then to the right 2. Open circle, down 1 to the right 2, and we could go the other way, doing the opposite. So up 1 to the left 2, up 1 and to the left 2. And now to connect the dots, we're just going to use that dotted line and label our graph. So this is y is less than -1/2 x minus 2. So now for shading. The shading, since this is a less than sign, that means we want to go below the x-axis. For the negative y, we want the negative y values. So we're just going to take our marker. So notice down here, to the left of the line, this is kind of like, this has all those negative y values that we want below the x-axis, and we're just going to shade it in. So that is the first inequality we have graphed. Let's look at the next inequality we have. So let's call this number 2, and let's bring this over here to the right. So we have 2y minus 2x is greater than or equal to 2. And again, we're just going to want to get into that y equals mx plus b form. To do that, we're just going to add 2x to both sides. So plus 2x plus 2x, and that will give us 2y is greater than or equal to 2x plus 2. So notice we still have this 2 here. So we want to divide that out and simplify this as much as we can. So let's divide 2 out on both sides. We end up with y is greater than or equal to x plus 1. So that works out really nicely. So now let's identify the slope and y-intercept. So the slope is just going to be 1 or 1 over 1. So we're going to be going up 1 and to the right 1. And now the slope b is just going to be 1. So before we make any points, let's remember to keep track of our inequality sign and see what inequality rules we need to use when graphing. So because this is a greater than or equal to sign, that means we're going to be using closed circles and a solid line. So now we can start graphing. So our y-intercept is 1, so we go to the y-axis and put a solid circle at 1. And then we're going up 1 and to the right 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And then we can go the other way as well. So let's connect our line, our dots, with our solid line. Label our graph. So this is y is greater than or equal to x plus 1. And now we got to keep track of shading, right? So for shading, we have this greater than or equal to sign. So that means we're going to want to go above the x-axis for all those positive y values. So above the x-axis is this way. So we're just going to shade this in. So now, we graphed both of our inequalities. So how do we recognize the solution? So notice where the two shaded regions overlap is right here. So I'm gonna highlight it even more with this brighter color so we can really see it. Any coordinate point within the shaded region will satisfy both of these inequalities and be an answer to this question. So now the question also wanted us to check. Let's just choose any point within the shaded region. So for this example, we'll look at this point 1, 2, 3, 4, minus 1. So this point is minus 4, minus 1. So that's what we're going to be checking with by plugging in x, negative 4 for x, and negative 1 for y. And now we're going to look at the first equation, y plus 1/2 x is less than negative 2, and plug these in. So for y, we're plugging in negative 1 plus 1/2 times negative 4 for x is less than negative 2. So let's see if this works out. So we have negative 1. This negative 4 times 1/2 will become minus 2. And then minus 1 minus 2 will give us minus 3. So now we need to ask ourselves, is negative 3 less than negative 2? And yes, it is. Now for the next question, the next inequality, we have 2y minus 2x is greater than or equal to 2. So we want to plug in negative 1 for y minus 2 times negative 4 for x. And do a little arithmetic, we get minus 2 plus 8. This gives us 6. So now we need to ask ourselves, is 6 greater than or equal to 2? Yes, it is. So we know that this coordinate point satisfies both inequalities and that our graph is correct. And if you're looking for more, check out the practice questions right here. The answers are up on my website, MathSux.org. The link is in the description below. And if this video helped you, please give it a like and subscribe. Thanks for stopping by, and happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!